bring in our last guest. Hi, Paul. How are you?
Hey, Jason. Long time no see. How have you been?
It has been a while, my friend. So good to see you. So good to be part of this project with you. Like I mentioned, you are our last guest of the day, going to give us kind of a roundup of what happened. There's been 4 amazing sessions that have kind of covered the whole gamut of IoT. And the one thing that I'm taking away from almost everybody is this feels like a really good time to get into IoT. Whether you got Raspberry Pis collecting dust in the corner like I do, or you're just now starting to like learn what IoT even stands for, it seems like we've got a lot of cool stuff for you to go play with. So I'm going to let you introduce yourself to the audience and maybe kind of take us from there.
Yeah, sure. So again, I'm happy to be here today presenting the introductory presentation for Get to Solutioning Strategy and Best Practices when Mapping Designs from Edge to Cloud. My name is Paul DiCarlo, and I'm a principal cloud advocate here at Microsoft and also lead for IoT advocacy within our developer relations group. So in today's session, we're going to cover 3 really big topics in the short amount of time we have. The first one being strategies for securing IoT device connectivity in real-world environments. We'll then look at how a common IoT solution architecture can be adapted to really outfit a variety of different business verticals. And finally, we'll look at putting it all together in an introduction to techniques for implementing artificial intelligence at the edge to support an intelligent video analytics IoT solution. So let's go ahead and get started. We're going to go ahead and begin by addressing really the big elephant in the room when it comes to Internet of Things solutions, and that is, of course, the concept of security. How do we enforce security in solutions that typically require the use of sensors in the real world, sometimes in publicly accessible areas? And as you might expect, it all really begins down at the device, but we also have to look into areas like the communication layer and, of course, take into consideration the cloud hosting environment as well. So we're going to go ahead and look at an overview on how Microsoft provides security for IoT solutions in each of these areas. So security concerns as they relate to IoT is a very real thing. In fact, if you consider recently the October 2016 Mirai botnet attack, in which roughly 100,000 IoT devices were taken over by hackers and turned into a botnet. That botnet was then used to launch a distributed denial of service attack, the immediate impact of which was that it knocked off the East Coast of the United States from the internet for an entire day, meaning no Netflix, no chatting, no online shopping. Now, think that's crazy. Imagine hackers getting access to your corporate data by way of an internet-connected fish tank. Sounds pretty unbelievable, but this actually happened recently to a big casino in Las Vegas where the attackers used a vulnerability in, yes, an aquarium thermometer to gain a foothold into the casino's network. And once they were in, they retrieved the casino's high roller database, which they then used to their advantage. But also, industrial systems are also susceptible to this type of attack. In the recent Triton malware attack, hackers intended to manipulate layers of built-in emergency shutdown protocols that keep plant systems up and running and bore deeper and deeper into the system. And if you think about this, if a malware can defeat plant safety shutdown protocols, then it can work to sabotage that system in countless ways, perhaps disastrous. Now, thankfully, in this attack, the malware accidentally triggered an emergency shutdown system that allowed it to be noticed and mitigated before it could do any real harm. Now, as we've seen here, security in IoT solutions is paramount. And IoT, of course, implies the presence of devices, often with access to mission-critical controls, sensor data, and maybe even access to real-time video in computer vision-based AI at the edge scenarios. And securing these IoT solutions requires mitigation across all of the relevant data pathways, beginning with the device itself, its communication layer to both internal and external services, which typically involve a connection to the cloud environment, which also implies needing to have security within the cloud environment itself. So Microsoft IoT services take security into account really in all of these layers of the IoT solution, beginning with the device, that pathway to the cloud, and within the cloud itself. And whether you're employing an IoT edge-based solution or a microcontroller-based approach with, say, something like the Azure Sphere, the Azure IoT security architecture that's built into all of our devices and SDKs allows you to monitor, again, beginning at that device level, and can provide you dashboards within Microsoft Azure for monitoring the security state across all of your device workloads within something we call Azure Defender for IoT. And this integration is really built in directly into the Azure IoT device SDKs, the IoT Edge runtime, and into the silicon itself in the case of the Azure Sphere hardware. So now you can kind of rest assured and have peace of mind that if you are building IoT solutions that are leveraging these Microsoft device SDKs and services or hardware, it means that security integration is available to your solution pretty much right from the start. And of course, within the Azure cloud itself, you can rely on security and disaster recovery options in each of the 60 plus and growing global data centers that make up the Azure cloud. And this availability is really great because it assures you that no matter where your devices are in the world, you can expect low latency connectivity and throughput with that ability to enable things like multi-region failover protection to ensure your IoT solutions are always up and running. And your security teams can also benefit from the protection that Microsoft Azure employs itself across its own data centers. And so this means that if your solution requires things like industry compliance standards, that's also another area where we're ready to welcome you with a current offering of 93, again, and counting available compliance offerings. Now, just like all the other sessions that you've seen as part of this all-around Azure IoT series, they're all backed by a longer 45-minute presentation that really goes into the nuts and bolts or the deep divey aspects of what we're presenting in these introductory sessions. And in the follow-up presentation for this session, we're going to go into detail on approaches that really show you how to adapt your Azure IoT solutions to accommodate what would traditionally be considered tricky environments in a secure manner. For example, if you have things like legacy devices that are not capable of running the secure device SDKs or the Azure IoT Edge runtime, which give you that security integration out of the box, that's okay. We can still ensure security across your communication layer by employing things like the Azure IoT Edge Gateway. And this offering will allow for a variety of configurations that you'll see listed here that can aid in adapting to the types of environments that may exist within, say, things like manufacturing facilities, offshore or intermittent remote environments, and even air-gapped internal networks that may have absolutely no outbound internet access at all. And in that session, we're going to go ahead and examine those configuration strategies and the environments they're best suited for in depth. And the goal there is to leave you, the viewer, confident that Azure IoT services can be leveraged in even the most challenging environments, provided that you have knowledge of the patterns that can enable secure connectivity for your workloads. Now that we've explained how Azure IoT solutions built on Microsoft SDKs and Azure Cloud Services can ensure security within even the most challenging network environments, we can now begin to have the conversation on how Azure IoT solutions might be relevant to your line of business and what those solutions would look like from an architectural perspective. So recent innovations have really allowed for the proliferation of IoT solutions across numerous industries, and it's no surprise that much of that innovation has been iterative, beginning with the availability of near limitless compute and storage that was brought on by the cloud revolution. And this has allowed for vast expansion in the ability to operate and process data transmitted by devices at scale. In fact, we're now beginning to see full circle effects of this as computing power is increasing to support and unlock new possibilities for small form factor edge devices, to the point that it's now possible to run accelerated AI workloads on devices not much larger than a cell phone. For example, this NVIDIA Jetson device that I'm holding in my hand right now. And as these innovations in cloud increase, we again get to see things like additional benefits, for example, with the adoption of digital twins, which now allows you to replicate physical environments into virtual spaces, allowing for a one-to-one mapping of the physical world to your cloud-hosted solution. We like to refer to this paradigm as digital transformation and see this potential of Internet of Things and AI at the edge as really the harbinger of mainstream AI for the masses. This is no longer an inaccessible field that's riddled with complexity and cost. It's in fact now more accessible than ever before, and arguably with a learning curve that invites anyone who possesses the desire to get started. We hope that we can inspire your line of business to seek the benefits of these artificial intelligence of things or AIoT solutions where they can make the most impact to your processes and customer experiences. Now, the cross-industry relevance of IoT solutions really pervades pretty much any industry that can benefit from increased value, reduced waste, or enhanced procedures via the introduction of real-time insights and automated systems that are capable of reacting to those insights. For example, in recent times, many businesses are facing the effects of return to work in the face of the global COVID-19 outbreak, and they have a need to ensure the safety of employees and customers. Automated systems for screening and reporting of visitor well-being are already demonstrating the ability to mitigate the effects of contagious infections using these IoT-based solutions. And within the medical community, this actually extends further. For example, the ability to monitor patients in real time has been critical during times of surge capacity in our hospitals across the world, and in helping to identify and properly assess patients who may be under quarantine. This can even extend further to additional medical scenarios, for example, things like smart blood sugar monitors or telemedicine in general. Now, one of the use cases that I think all of us are familiar with, or at least have heard about, is the futuristic vision of self-driving vehicles, which is at its heart also an IoT solution. One that really clearly demonstrates just how fast insights can be enacted upon at the edge, to the point that these self-driving vehicles can recognize potentially catastrophic events and respond to them safely and in real time. This effect can also be extended to additional things like, say, smart factories, which can utilize these similar concepts to do things like reduce downtime by automating, say, their quality control systems, and allowing for things like increased production and reduction in defects along the way. Another cool scenario for this is things like energy companies can leverage IoT data to adapt to things like demand spikes or energy surges, where they can recognize them almost in the moment as they happen, and then being able to turn over that data to provide additional value to customers downstream by being able to do things like automatically dialing down their HVACs or heating and cooling systems during these peak energy usage events. And finally, in retail areas, we're also seeing this ability of adopting IoT solutions to do things that can allow us to gauge customer behavior inside of brick and mortar stores with a fidelity that really mirrors that of online analytics, ultimately allowing for enhanced customer experiences by reducing shelf vacancy, optimizing reorder frequency, and giving the potential to offer product suggestions to customers in the moment based on perhaps what they're looking at, where they are, things that they've noticed or bought before while they're inside that retail environment. Now, as you've seen, IoT solutions can address a variety of different use cases, but it's interesting to note that in all of the examples that I just gave, that pathway from device to the cloud to the line of business application is really kind of similar. There are, of course, variations of the specific technologies involved when encountering these types of solutions in the wild, but workflows that involve using things or devices to capture and produce insights, which then lead to action, is really common to all IoT solutions. And once you understand this fundamental concept, you can apply it to a host of business scenarios to create relevant IoT solutions that can leverage real-time insights and really affect your ROI or bottom line in your industry. Now, we can extend this concept even further by using a common architecture for IoT solutions that are built on Microsoft Azure, by employing service offerings that are designed specifically to address this common workflow. Our things are really just IoT devices that communicate using those secure Azure IoT device SDKs, either directly to an IoT hub or by means of an IoT Edge gateway. And once that data arrives to the cloud, we can begin to process and operate on the insights contained within using services like Stream Analytics. And that can allow us to do things like filter relevant information while our telemetry data is in flight. This can allow you to extract time-critical insights into things like warm storage systems that will allow you to use them immediately, or you could offload that data into cold storage systems for archival purposes. The key takeaway here is that once your data is in the cloud, scalable integration of that data into line of business applications that can then take action on the data produced by our devices becomes very simple to connect using the available services within the Azure cloud. So what do these services look like in practice? We've covered a lot of the theoretical concepts here and laid out how you can do things in a secure manner. But now what we want to do is show you how you can really truly develop these state-of-the-art AI at the edge solutions using the latest concepts in computer vision. And to demonstrate this, we're going to explore a real-world project that was developed using NVIDIA embedded hardware and Azure IoT services to produce a generic solution that can consume multiple video sources to produce insights at the edge and in the cloud using a custom object detection model. So specifically, we're going to develop a solution that targets an NVIDIA Jetson embedded device. And this is currently a $60 2 gigabyte onboard memory with a GPU slapped on top that can allow you to do GPU accelerated AI inferencing on a very small form factor device. And in that follow-up session that we're going to link to at the end of this introductory session, we're going to give you full instructions that will enable you to replicate this solution for yourself, and of course, point out any of the areas of customization that could allow you to adapt the solution to detect really any object or objects that you train it to, and demonstrate just how easy it is to integrate the data produced by this device into a variety of Azure IoT services. Now, because the resulting solution is built on Microsoft Azure, it is naturally aligned to the Azure IoT reference architecture. And that means that our IoT device is going to be instrumented with something that can communicate with Azure IoT services. And in this case, that will be the Azure IoT Edge runtime, which is going to allow us to directly communicate to an Azure IoT hub. And then on the device, we're going to employ a custom object detection model that's been developed using our Azure Cognitive Services custom vision service, which will supply object detection results to a stream analytics service that will both run on the device as an IoT Edge module, and also a backing stream analytics service that will run in the cloud that will filter results. And those filtered results will flow from our stream analytics service into visualization services like time series insights and Power BI, which you've probably seen in previous presentations. Both of these services will take advantage of the warm path to allow for near real-time display of that data. And it's going to also have a concept to be able to support things like ML operations or ML ops by having a camera tagging module that will allow you to very easily capture frames from any videos that are connected to your device on site, which you can later use by mirroring them into cold storage as training samples to enhance your model over time. And of course, based on all of the features and facets available within the Azure cloud, we'll show you how you can enable creating new models and then deploying those down to your device while it's in production. So at the end of that follow-up presentation, you'll be ready to apply the Azure IoT reference architecture to create custom intelligent video analytics solutions that can really address a variety of use cases. For example, by modifying the objects being detected and ensuring that you're capturing any data that's relevant to your business solution, you can put Azure IoT solutions to work for really any IoT-related industry. Microsoft's own Project 15 was born from this approach and produced a solution that assists in conservation and protection of the world's elephant population by using this same demo application. In fact, the main changes here is that we adapted the object detection model to detect what you would probably assume is elephants, and of course, updating the business integration component to allow for visualization of where those elephants have been seen on an interactive map. You can learn more about Project 15 by visiting aka.ms/project15. Now, for links to the relevant documentation, resources, and demos used in this presentation and the follow-up presentation that I've alluded to, you can check out aka.ms/IoT50/resources. And if you're interested in using this presentation, or really any of the presentations that have come before, or the video recording of this event for anything that you'd like to use, maybe an event of your own, those materials are open source and can be found on GitHub at aka.ms/IoT50. And if you enjoyed this session and are interested in any of the other topics that are covered in the IoT event learning path, you can find them all at aka.ms/IoTLP. Now, we covered quite a few topics in this session, and I would like to share that we've curated a collection of modules on the Microsoft Learn platform which pertain to the concepts and topics covered in this session. This can allow you to interactively learn how to build and securely connect IoT devices to the cloud via the use of an IoT Edge gateway, building intelligent edge applications using IoT Edge, how to create solutions with IoT Central, and covers details on how to implement stream analytics both in the cloud and on the edge. And finally, this presentation and the associated Learn modules can help guide you on a path to official certification. If you're interested in obtaining an accreditation that can help you stand out as a Microsoft certified IoT developer, we recommend checking out the AZ220 certification. You can find details on the topics covered and schedule an exam today at aka.ms/IoT50/certification. And I'm going to leave you with just one more thing here. If you are interested in any free interactive learning content, Microsoft Learn is a great resource provided at microsoft.com/learn that can allow you to begin your own custom learning path using resources on the latest topics and trends in technology, not just IoT, really anything out there. And with that said, I'd like to thank you for attending this session and wish you luck on your IoT education journey.